Hello and welcome to the Analog Devices Precision Digital Isolation Technology Training videos. This video is the second in the series and will focus on the characteristics of isolators. There are four essential components of an isolator device: the insulating material, the coupling element, the data transmission method, and the packaging. The insulating material provides the high impedance necessary to limit current flow, which is the primary function of an isolator. The coupling element is the electrical device that transmits information or power across the insulation barrier. In the case of an iCoupler insulator, it's a microtransformer. Data is almost always encoded in some fashion to accommodate the signal characteristics of the coupling element. For example, transformers cannot pass a DC signal, so the data must be encoded to contain that information in an AC signal format. The chip package houses the entire structure, but also becomes a secondary insulation system in parallel with the main isolation barrier. Its characteristics may limit the performance of the isolator in certain conditions. There are many ways to design and manufacture isolation devices. Historically, opto-isolated devices, also known as optocouplers, were used. An optocoupler contains a LED as the input device and photodetector at the output. Data is transmitted by biasing the LED, which produces a current on the other side of the isolation. The opaque mold compound separating the LED and detector provides the insulation. These devices were used for decades, even though there were many parametric drawbacks that hindered system performance. A new approach invented by Analog Devices, digital isolation, was introduced to the market in 2001 as iCoupler technology. These devices use microtransformers fabricated on chip as the coupling element, with polyimide insulation between the transformer coils. Analog Devices also offers micromodule isolators that use transformer coupling through a BT laminate substrate. Over time, other approaches have been used to produce digital isolators. Some isolators use capacitive coupling with silicon dioxide, while others use transformer coupling with silicon dioxide. The pros and cons of each approach will be discussed in later sections. Let's talk about iCoupler technology in a bit more detail. This diagram shows a cross-section of a standard silicon wafer in gray, with metallization shown in blue. That top metal layer is used to create one of the transformer coils. The lighter blue material is the polyimide, deposited in multiple layers on top of the wafer. Gold coils are patterned on top of the polyimide, and a protective layer is then blanketed over the surface. This diagram shows the stack-up in a different perspective to help you visualize it. In these photos of actual iCoupler products, the data coils can be seen as the small gold-colored circular features. Products that transfer power use a larger coil structure. Standard silicon wafer processes are used for the basic communications and power functions, with the polyimide and gold coils deposited in a dedicated internal foundry. As noted previously, micromodule technology also uses transformer coupling, but a different insulation material. These products are in a standard BGA package format that contains a BT laminate material, which is visible from the bottom. The BT laminate serves as the insulation. If we look inside the package, we can see the individual elements that form the data and power isolation. Coils are patterned into the inner layers of the laminate to provide the data communication functionality. A power transformer is also integrated into the packaging, which provides high power capability and improved power transfer efficiency. Many support components can be integrated, making the products very easy to design with. Micromodule technology is complementary to iCoupler technology, offering many benefits including higher output power, higher efficiency, wider temperature range, lower radiated emissions, and improved ease of use. Analog Devices has many digital isolators that provide trusted safety and data integrity. To learn more, watch the next in our Precision Digital Isolation video training series. Click on the link below or visit analog.com/iCoupler.